Adjunct Professor Moran, Microeconomics 112. In this handout we're going to calculate total product, marginal product, and average product. Then we're going to convert that to marginal cost. We're going to compare that with marginal cost, which is really where we want to go. And we'll never be talking about total product, marginal product, or average product again. The reason this is done is because it's easier for the students to understand total, marginal, and average when we talk about boxes falling off an assembly line. And once you have those concepts, we can start talking about marginal cost and average cost, which is really what we need to understand to go forward when we discuss different types of business competition in future chapters. So there are many different types of costs. You'll be concerned with fixed cost, variable cost, total cost, average cost, and marginal cost. These economic costs are costs of production. In the final analysis, these costs are opportunity costs. They could have been used to produce something else, for example. These costs depend on how efficient the production process is. The efficiency of the production process is affected by the law of diminishing marginal returns, which we discussed in a prior video. This activity shows how the law of diminishing marginal returns affects production and how changes in production efficiency affect costs. Okay. Let's add 10 to these. So if you don't, you think all you have to do is divide this number by, just subtract these to get marginal product, but you don't. You have to divide column 2 divided by the change in column 1. So it's the change of this divided by the change in this. But when these only change by 1, that division is masked. So we're gonna call this 100, 25, 250, 370, 470, 600, 630, 630, 620, 10, 20, 30, 40, 50, 60. So this is constantly changing by 10. This is changing by 150, 120, 100, 80, 50, 20, 0, and minus 10. So you should be able to calculate marginal product when you're given total product and input. So this changed by 100 and is changed by 10. So that's 100 divided by 10 is 10. This changed by 150. This changed by 10. Marginal product is 15. This changes by 120 divided by the change in input of 10 is a marginal product of 12. So when you hire your first 10 workers, your total output goes up by 100. So you're divided by that, the change in input of 10 into the change of output of 100 gives you a marginal product of 10. Another 10 resources are added and output goes up by 150. So the change of 150 divided by the change of 10 gives you the 15. Right, so change of 120 divided by a change of 10 is a marginal product of 12, and so on. Now here you should notice that these numbers are getting larger, so this is increasing marginal product. Here these numbers are getting larger but at a slower pace. This is diminishing marginal returns. And finally, we have negative marginal returns. So although there were 3 stages, the law is actually named only after one, diminishing marginal returns. There is a synergy that happens when workers first start working together, and output will go up, but it'll go up, not only will output go up, but it'll go up at a faster pace. But eventually, the factory becomes, say, slightly more crowded, and you lose some efficiency by adding additional workers. Output goes up, but it goes up at a slow rate, diminishing marginal returns. And then the factory gets so crowded that adding additional returns results in negative marginal returns. The principle of diminishing marginal returns explains why a flower pot can't feed the world. So in other words, if you add a seed to a flower pot, you'll get more output than you had before. Add another seed, and you may get so many more buds off of that plant that you've more than doubled your output. Your output has gone up at a faster rate than it did before. But eventually, if you keep adding seeds, your output may go up, but it'll go up at a slower rate as the plants start to crowd each other. Eventually, you add too many seeds and they all die, something like that. And that's why you can't feed the world from the flower pot. This explains how output changes and at what rate it changes when you add variable output to a fixed plant capacity. The rate at which marginal product changes when you add a variable input to a fixed plant capacity. This law only applies in the short run, because in the long run, even the plant is variable. Whereas in the short run, only your variable inputs are variable and your fixed plant is unchangeable. Hence the catchy word fixed. Okay, we're going to graph this information and see what shape this curve takes. So you have to find your matching data, the quantity of input, and the product. So I've copied this. Quantity of input and your total product is what we're going to be graphing here. And here we're going to graph marginals. We're going to graph the marginal and average product. So your average product was just your total product divided by your input. 10 divided by 1, 25 divided by 2, 37 divided by 3, 47 divided by 4, average product. Okay, so here is total product in 1 and 10, 25, 25 and 2, 37 and 3, 47 and 4, 55 and 5, 60 and 6, 63 and 7, 63 and 8, and 62 and 9. And there's a graph of your total product. Now we can graph marginal product with the addition of additional units of labor. So these are the numbers we calculated on the prior page. Okay. Marginal product and average product. Let's see if we can get this to look better. Okay. Oh, they're going to graph these in here. Okay, 0 and 10. 2 and 15. 3 and 12. So here's 3 and 12. 4 and 10. 5 and 8. 6 and 5. 7 and 3. 8 and 0. 9 and negative 1. that is marginal product. Okay, now we're going to calculate average product. 1 and 10. 2 and 12 and a half. 3 and 12.3. 4 and 11.75. 5 and 11. 6 and 10. 7 and 9. 8 and 8. And 9 and 7. 5. 5 and 11. Okay, we connect the dots. And this is your average product. And we need to explain why, when marginal product is falling, average product is still rising, if you notice this here. And that's because if you think of your test scores, if you get an 80 on a test and then get a 90, right? Those would be your marginals. Your average will rise. If your next test score if your next test score goes down, that's your marginal. So here's your average, 80, 90. Even if your next test score goes down to an 85, as long as it's higher than your average will still go up. So here's your marginal test scores going up, and now your marginal test scores are starting to go down. Notice that your average will still rise. Take test after test, your test scores are going up, but then they're going down. As long as this, even when your test scores, your next test scores start going down, as long as they're higher than your average, it will drag your average up. But once your next test score is lower than your average, it's going to drag your average down. Now, when we start talking about marginal cost and average cost, this is going to be very important to see when we're freehanding the graphs. Okay, so what happens to total product as output increases? What happens to total product curve as output increases? It rises. What happens to marginal product as output increases? Marginal product first goes up and then starts to decline, representing the law of diminishing marginal product. What happens to average product as output increases? It rises and then starts going down. But it starts going down after marginal product starts to decline. Why do these graphs look like they do? Because of the principle of diminishing marginal product that explains all short-run relationships with respect to output and cost. What is the law of diminishing marginal product? As you add successive units of variable input to a fixed plant capacity, output will at first go up at a faster rate, then it will go up at a slower rate or diminishing rate, and it will turn negative. Why is this concept important? It describes how output reacts when you add additional units of variable input to a fixed plant capacity. It explains cost behavior, which right now we're dealing with products, but we'll eventually deal with cost. What is the relationship between marginal product and total product? Marginal product is the slope of the total product curve. Okay. And what is the relationship between marginal product and average product? As marginal product rises, so does average. But as average declines, marginal product will continue to rise until marginal product crashes through average product, and then it'll start to drag average product down. intuitively, if you think about product and cost, if you're getting a bigger bang out of each worker, if each worker is adding more, an increasing amount of output, increasing marginal returns, then since each worker is costing the same amount, marginal costs would be falling. But once marginal product starts to diminish, once equal cost workers are added, but they're adding more output but at a slower rate, then your marginal costs will rise. And so these costs and product curves are inverses. And now we have an intuitive understanding of marginal cost and average variable cost. We'll continue and focus on costs instead of product.